Hello, everyone, and welcome back to the virtual Eclipse Community Meetup. I'm your host, Stephanie Swart, and today I'm joined by Maximilian from Eclipse Source. Today's meetup is on developing business web applications with form-based UIs. So without further ado, Maximilian, the floor is all yours.
Hi, everyone. Thank you very much for the introduction, Stephanie. Let's dive into the slides. You will not be able to see me from that point onward. Just one thing ahead of time. In case you have any questions, feel free to post them to the group chat. Stephanie will watch for your questions and she will alert me to questions that might be important right away. And anyway, we will have some time to discuss questions after my presentation. So I hope you can see my screen now with the slides. So the topic for today is developing business web applications with form-based UIs. And I'm going to look at a particular framework to do that, which is part of the EMF Forms project at Eclipse. And the framework is called JSON Forms. Before we dive into the technical details on that, let me first start with the problem that we're trying to solve with that framework. So in many business applications, you have a lot of data, and that data is frequently edited or viewed in forms, such as the form that you can see below here. And those forms typically contain controls for different types of things that you can put in, like text or dates or numbers or enumerations that are drop-downs. And in many business applications, you have quite many of those for the different entities in the business application. In the example that I'm using here, I'm using a form for tasks, but we will go into detail on that example in a minute. Now, when you have to create such a form, basically what you do is you map an entity from the data that you have, such as a task, onto some form-based UI. And in this concrete example, on the left-hand side, I have a task class. And this task has a number of attributes. It has an attribute name, which is a string, an attribute description, which is also a string, an attribute due date, which is a date, and an attribute done, which is a Boolean. And it will later on in the ongoing example have a couple of more attributes, but you get the general idea. And usually what you do is you project those onto a form, and then people can edit the data in this form. So for example, the name would be a name field here. Usually you also add a label so that people know what to add in that particular input. We have a description. Although a description is also a string, it is represented differently here because a description in the form is usually something that is multi-line. So you want to have a multi-line widget there. We have a due date, which is going to be a date picker. But you can see in this form, for example, we changed the order of those attributes. They are not displayed in the same order as in the data model, obviously. So that's something you want to change when you create a form for some data. And you can also see that the layout is not just a one-column layout with all the controls. Some things are in two columns, like the due date and rating here, or the recurrence and recurrence interval. And finally, done is mapped to a Boolean control here, and it's displayed at the top because for tasks, it is maybe very important to be able to quickly check the task so that it's completed. So this is the general idea, and that's also the general idea of JSON Forms, to be able to map data into a form in a quite straightforward way, which we will see. Now, there's two main ingredients for that. The first ingredient is a declarative data definition. As the name implies, it defines how your data looks like, but not in a programmed way. So you would not program POJOs that basically have getters and setters for the different properties of your model. It describes it in a declarative way. So you have a textual artifact that describes your data. And the standard we use for that is JSON Schema. So what is JSON Schema? It is like XML schema, just for JSON. So it describes JSON instances. I have an example here on the right-hand side, but we will look into the details of JSON Schema anyway. And basically, JSON schema is a format to describe those JSON-based data instances. It has a focus on data validation. That's where it comes from. So it also supports syntax for describing not only that, for example, the property name. You can see that on the right-hand side. Guess you can see my cursor, that the property name is a string. You can also say, well, this string has a minimum length, or it has a maximum length, or a number can be formatted in a certain way, all those things. Of course, you can just create a JSON schema for your data manually. And if you just create a web application, that's probably the way to go, right? You create schema for that. There's even some editor support. But another frequently used workflow is to generate it from another artifact, because maybe you already have a data model. You have an XML schema, or you have an eCore. So you might only want to derive a JSON schema for that, because in the web front-end part of your application, you like to use JSON. So the bottom line of that is we use JSON schema in JSON Forms to define the data. That's also why in the remainder of this talk, I'm often referring to the JSON schema of the data as data schema, because it describes the data. The reason why I say data schema is also to distinguish it from the UI schema, because the second main ingredient for using JSON Forms is a declarative UI definition. The idea here is the same. Instead of programming how the form looks like, we have a declarative artifact that describes it. It is not a general purpose UI language. It is a language that's really only focused on form-based UIs, and that helps to keep it really simple. It describes the layout of a form. It also describes the data binding of a form. We will look at that in detail, but just for now, if you have a text input field on the form, you need to know which data it displays from the JSON data that you have at hand. And you need to know which value to update in case the user types something into that text box. It does not describe the data itself, because for the data itself, we have the JSON schema, that is the data schema. It does, however, reference the data schema, and we will look into that as well, because it needs to say, well, I would like to have an input field here, and the data from that for that input field comes from a certain attribute from my data model. So all in all, a UI schema in JSON Forms is used to define the form-based UI. Now let's put those two together, because that's what JSON Forms is all about, to combine the JSON and UI schema. And this process of combining it is also referred to as rendering. The idea is that you take a JSON schema that someone has defined, that defines the data, represented that here as a human class diagram. You add a UI schema, which describes the layout of a form. And somehow, magically, you get a live form in your HTML-based user interface. And this magic is called the renderer set, and that's the main component of JSON Forms. A renderer set produces an actual live UI from those two artifacts. Now, those pictures, of course, are not accurate. In fact, those are two textual artifacts. So let's look at how those textual artifacts, what the purpose of those is and how they work in more detail. There is two important concepts in a UI schema. The first concept is controls, and the second is layouts. And I would like to look at controls first. So what is a control? If we look at this representation here, a control is, in very general terms, some input element where you can edit a part of the data, usually exactly one property or attribute. So in this example, a control is, for example, the input field for the name attribute and the label that tells the user that you can input the name attribute here. A control is also responsible for more things that we will cover later. For example, a control can also have a validation state. We can see that on the right-hand side here for rating. Rating, the rating control here is in red because it has a validation violation. So all the functionality is usually related to a control. So basically, this control in the UI schema will later on be rendered into what we can see in the red box on the right-hand side, on the user interface side. So it will render a label name, and then it will render a text input field because we have some text here that we want to edit. And it will also, of course, render the values that are maybe already present in the data object in the attribute name. And all that will be done by one renderer. So I had said on the previous slide that the entire form is rendered by a renderer set. And the way this is performed is that JSON Forms will look at the different elements in a UI schema and then pick a renderer that is suitable to render that particular part. So if it encounters a control in the UI schema, it will pick a renderer that can render that control. For example, a text field renderer, and that will then produce the actual UI in that part. And of course, that's not enough yet. We also need to know which attribute from the data model is being visualized there. So the UI schema has to have a pointer to the JSON schema to say, well, in this control, actually what I want to visualize is the name of a task. Now, let's look at the actual textual artifacts there. In the UI schema, we have a control here. It can have more attributes, but that's kind of the minimum. It says that it's type control, so that we know that it is a control. And this control is responsible, or this declaration in the UI schema in the red box is responsible for rendering the red box on the right-hand side, a name label with a text input field. In addition, this points to a name declaration in the JSON schema. So this JSON schema on the right-hand side says, well, I have an attribute that is called name, and this attribute is of type string. And in addition, it says that the minimum length of that attribute is 1. And the way that the UI schema references the JSON schema can be seen here in the scope attribute. The scope attribute points to the properties and then to /name, which is the name attribute in the task in this example. So this is the data binding that I talked about earlier. The UI schema does not repeat the definitions that are already done in the JSON schema, just points to them. So by this pointer, for example, the UI, the framework, and in this case, the renderer rendering the name control already knows that if someone would input only a 0-character name, then this would not be a valid name, and it had to show a validation message that would remind the user that you have to add some more characters here. Now to the second important concept, apart from controls in the UI schema, that is layouts. If we only had control in the UI schema, then we would not be able to create some more complicated layouts like the one that we can see here on this task form. In that particular case, I want the name control to take the entire horizontal space, but then below that, the due date and the rating, they can share that horizontal space. And the way that is expressed there, I will only introduce basic concepts of the layouts, and the way that is expressed with two basic concepts in JSON Forms with the UI schema is to say, well, first of all, I have one column that's called a vertical layout, and it has 2 rows, one row for the name and one row for due date and rating. And due date and rating in turn are contained in a horizontal layout, which has 2 columns, one for the due date and one for the rating. So let's look at the actual declarative artifact, the UI schema. How does that look like? Well, first of all, you have a vertical layout that basically says that we have one column. And then this vertical layout has child elements. The first child element is a control that binds to the name. So this will be responsible to put the control as the first row. And then we have a second row, which is a horizontal layout. And if we then start decomposing the horizontal layout, we can see that, again, it has two children, the due date, which will be rendered on the left-hand side, and the rating, which will be rendered on the right-hand side. So with this vertical layout and horizontal layout, you can also already express a number of forms. There's more complicated concepts available, such as, for example, a tree master detail. But to initially understand the layout concept in JSON Forms, that's a good starting point. Now, having explained all that, maybe you would like to see how that actually works, and I have prepared some demo. So let's dive into the demo. What I've done to prepare that demo is actually not much. I've went to the JSON Forms website and followed the 3 getting started steps. And one of them, the first one, is to check out a seed repository, JSON Forms React seed in this example. A seed application is a very minimal example application that showcases the use of JSON Forms, and we can use that for this presentation to show you how to get started and what the different features are. The first thing you need to do is you need to run npm run start to start a development server and show the current form in the browser. And the development server will also update the browser whenever I change something in my app. So this is the minimum seed example app that we're going to look at. On the top, there's just some header. And then here in the middle section, we have bound data. That's just for demonstration purposes. It visualizes the current data of the form, and it will also be updated live. So we can see that in this data object, name is already set to something, name of the task. Description is already set to something, done is already set to something. And when I start using the form and editing it, it gets live updated. So you can see here what would happen to a data object that you would pass into JSON Forms. If I change something here, it's just updated live. Now, what I have here is an Eclipse instance with the source code for this React seed. If you're not familiar with React, I will maybe use some terms or concepts here that you are not familiar with. That doesn't matter too much because the basics that concern JSON Forms will be the same even if you use Angular or even another web application framework. Now, first of all, what you would have is the index HTML. That's not super interesting. And corresponding to that, you have an index.js. That's much more interesting. If we look at the index.js, one thing that we define here is we import a schema. We will look into that in a minute. We also import a UI schema from a file. And then we just declare as a constant in this simple example, usually you would probably pull it from a REST API, a data object. And we just define that in place. And that's also why there was some initial data in the form, because in this data object, I just put in some values so that it is not an empty form in the beginning. If you think about an actual web application, maybe the user has searched or requested some object from the server that should be edited. So you usually have some initial data, unless you just create new data. And then we set up, that's a concept from React Redux, we set up a store, which is basically representing the state of the application. And the important thing that we do on the store is also initialize the state of the application in terms of the data that's going to be edited in the form, the schema of that data, and the UI schema of the data. That's usually the 3 parts that you have for a JSON Forms application. Just a side note, JSON Forms is also capable to just take a data and then derive the schema and the UI schema, but obviously then you can't influence how the UI looks like. It will just be auto-generated. But as a starting point, it's often useful. And now that we have created the store, we actually need to render something, some HTML. And what we render is the app. So the next step is to look into the app.js, because that's the actual React app. And the React app now shows the 3 parts that we've seen earlier. If we switch back to the browser for a second, we've seen that we have this header section, we have the bound data section, and below that we have the actually rendered form with JSON Forms. And we can see that represented here. This is the header section with the logo and so on. This is the section that contains the bound data. It just displays the current data as a string. And here we have the form section, and this is the important magic tag, so to say, the JSON Forms tag. Because this tag, at this very location in the DOM later on, the form will be rendered into, and it will use the data, UI schema, and schema that we have put into the store. Now, finally, what we haven't seen yet is the schema. So this is the JSON schema of the data that I have prepared. It has some things that we've already seen. So we have a name property here of type string, description, done, due date, and some more properties like rating. Rating, for example, has a validation constraint here that it has a maximum. We have an enum type string. So this string has only a couple of values that you can pick. And we have this recurrence interval. And if we look at the UI schema, then we can see that we have a control for the done property from the schema. In this case, we don't want to show the label. We have a control for the name. Then we have this horizontal layout that we looked at earlier, which then has two columns, one for the due date and the rating, and so on. So this is the UI schema that we use for this particular application. And all that is now live anyway. So if you would, for example, introduce this validation constraint that we had seen earlier on the name, so that was on the earlier slide here, that we have a min length on the name, we could now in the demo just add that to the current demonstration. Put min length of, for example, 3 characters in here. And I just save the schema. And when I go back to my actual application and I remove this here, then it tells me that there's a violation. And as soon as I have 3 characters, it is gone. The same also applies to the UI schema. So if I would do changes in the UI schema there, they would also get immediately reflected. So for example, I could move the description control into the horizontal layout. So I just pick that. And move it within horizontal layout here. And the changes are immediately picked up. I mean, it doesn't look great, but it shows you now we have 3 columns for the horizontal layout. Let's move that back. So this is the initial seed application and the initial functionality that just works out of the box. Now let's go back to the slides. The first feature that I would like to show is validation, because that's a very basic requirement that all of the web applications usually have. And the validation feature is mainly driven by the JSON schema, the data schema. We have seen that we can just add validation constraints there. I've added a validation constraint on the name. And the renderer for that particular control is then responsible to actually display those validation constraints. We've seen this other validation constraints on rating, where the number should be smaller than a certain number. And if we look at the actual form, we've partly seen that already. You get these validation constraints, and if you put in a number that it's too high, it's the same. This is very useful because you can do client-side validation there, and actually you can even reuse the same JSON schema on the server side once you receive the data through a REST API and then validate again. So you could have a single source for your validation constraints there. The second feature I would like to show is visibility rules. That's also a very commonly needed feature in forms. The idea here is that you have an attribute, and based on the value that this attribute takes, in our case, recurrence, a certain part of the form is visible or enabled or invisible or disabled. So in our example, we have this recurrence attribute and we have recurrence interval. And whenever recurrence is put on never, it doesn't make any sense to put in a recurrence interval. So we want that this control for recurrence interval will not be visible or at least be disabled. And as soon as you would switch recurrence, for example, to daily, then it would become enabled and you could actually enter a value. Now, if we look at the UI schema, we have a case for that in here for the recurrence interval. And if we take a look, we see that we have a control here. And the control binds to the recurrence interval attribute from the schema. And in addition, it defines a rule. And this is how this conditional visibility is implemented. The rule first says what the effect should be in case the condition of the rule is true. So the effect here is to actually hide the entire control. And the condition to hide the control is a value from the data. And in this case, it is pointing to the recurrence attribute. So whenever the recurrence attribute is set to the expected value of never, then the entire control will be hidden. So this rule is already active. And if we switch over here and we set the recurrence interval to never, you see that the control will be hidden and it will only occur when you select a different occurrence interval. And this is also something you can just change live. So for example, I could also say, instead of hiding it, I just want to disable it in case the value is never, so that you can't input something. If we now switch back and we put in never, then it's not hidden, but it's disabled and you cannot enter any values there. And when you switch to a daily, then it's enabled again and you can input some stuff in here. And then one more concept that is also frequently used in JSON forms is custom renderers. You have seen that based on the different types that you have in your JSON schema, we have a renderer in the core that is able to handle that case. So we have a text renderer, we have a Boolean renderer, we have an enum renderer, we have a date renderer, and so on. So all the basic types are covered. But often enough, you might want to have something displayed in a different way, different than the renderer that is shipped with the core would render it. And a good example is rating. Rating is currently displayed as a number, but it would look much nicer if we would just ask for a 5-star rating, and then you can just select a different count of stars, and that would then be the actual rating. So let's look at that example. If we would like to have this, what we need to do is we need to register a custom renderer. I say custom renderer now, but in fact, it's just registering a renderer because all the existing renderers have just been registered exactly in the same way. And the idea here is to say, well, I want to be responsible for rendering a certain element from the UI schema, for example, a control, and I only want to do that under certain conditions. I have prepared a line in here to do exactly that. So I will register a render in the state of this application. And the registration takes 2 parameters, rating control tester, which is responsible to tell the framework whether the rating control renderer wants to be responsible for that particular part, and the actual rating control renderer. So let's look at those 2 parts. The rating control tester now is only supposed to say whether the rating control wants to be triggered for a certain UI schema element. And there is some predefined functions there, but basically you can express an arbitrarily complex condition For example, the condition could be for all string controls, or only for string controls where the value has a certain number of characters. And in my particular case, I want to be responsible with a priority of max value of number. So yeah, in any case, and only when the scope ends with rating. So effectively only for the rating attribute. And then in case I am responsible, I need to create some HTML. This is the HTML I'm going to create. So I'm going to reuse a rating component from React. And this rating component takes two attributes. It takes a value, which is the value of how many stars are currently checked. So I can just pass in data here, because I can request a number of values from of different parameters from the framework that I can use in my HTML. So what I requested here is data. That's the current data value. So this will be the value of the rating attribute. I've requested to get a handle change method. The handle change method is a callback where I can propagate a change in the data that I display, and we get the current path in the schema. So what I will do is I will pass the data to the value attribute, and then rating also allows to register an on-click handler, and I will just implement a very simple method. Whenever an event arrives, I will trigger the handle change method that I got as a parameter, and I will pass it the path of my current data and as a number the value of this event, and the value of this event will be the number of stars that have been selected. And that's already everything to it. If we switch back to our example, I have now the registration, enable the registration. So for the rating control will be picked, and you can just pick a number of stars, and it will update the rating value accordingly. Now, initially I said that JSON Forms is a component of EMF Forms. So in some way, it must be able to use EMF Forms and JSON Forms at the same time, and of course it is. If we just recap, or in case you don't know, EMF Forms models its data with EMF eCore, which basically corresponds to a UML class diagram. And then it has an artifact that in EMF Forms is called viewModel. It describes the actual form-based UI. And then it renders a user interface, for example, with the SWT renderer, so that it can show within an Eclipse instance. And if you compare that with what JSON Forms does, it's pretty much the same, right? The eCore seems to correspond to the JSON schema, and the view model seems to correspond to the UI schema, and that's exactly the way it is. So what we did is, to support that, is we have an exporter that takes an eCore and generates a JSON schema from that. And we have an export that takes a view model as an input and generates a UI schema from that. And this way you can run an EMF Forms application and have your forms modeled within an application that maybe runs on SWT inside Eclipse RCP. And you can, in parallel, reuse the same eCore and view model that you've already created and run, let's say, a React application in a web browser. So let's do that. I have here, the Eclipse that I have here is just the modeling tools package, Oxygen 3. And it ships with EMF Forms already. So I can just pick one of the examples that ships with EMF Forms and just pull that into my workspace. And this example consists of a sample E4 application that I'm not going to use, consists of a model that models a task. So let's have a quick look here. We have a user and a task, and the user has first name, last name, and a couple of attributes. And then we have a view model. This is what corresponds to a UI schema, and this view model has some horizontal layout with groups, but since there is a preview functionality, we can just take a look. This is how it's going to be rendered in SWT. So we have two groups, a primary and secondary group, and then we have a list with tasks below here. And the functionality of exporting that to JSON Forms, you can invoke that from the view model. there's an entry EMF Forms and export to JSON Forms here. And the first thing that it is going to export is the eQuar. So I have to browse a location where I would like to put the data schema to. I'm just going to use my workspace. And in addition, I'm going to just override the existing schema. And then on the second page, I have to pick a location for the UI schema. Again, the workspace, and again, the React app and the UI schema in that app. And I just replace those, overwrite and overwrite. And the export seems to have been successful. And now when I, oops. Now when I go back to the browser, I get this form rendered, and it's still data bound and all the same. It's just rendered in a web context here with an array control for the tasks and all the properties in here. Oh, let's just have a small recap. So what is JSON Forms in a nutshell? The key features are you get a format to declaratively define form-based UIs. It has strong support for validation, so that the validation constraints from your data model are validated and are visualized in the forms. You have a concept of visibility rules, so that you can show or hide or enable or disable parts of the forms based on values that have already been input. You can extend it very well. One important concept to extend JSON Forms is custom renderers, so that you can visualize certain parts of the forms different from how the core renderers would do it. And you have a quite tight integration with EMF Forms, so you can even single source how your forms look like, because you just create a view model in eQuar once, and then you generate the artifacts for JSON Forms from that. Having talked about the renderer sets, what we've seen in the demo is a material UI-based renderer set. It's quite simple to create a new renderer set. We also offer a second renderer set that is not dependent on any UI toolkit. We have a vanilla renderer set available that's also more open to custom styling. And we have available seeds. We have seen the React seed that I've used here. There's also an example for Angular to exemplify the use of JSON Forms on Angular. If you would like to get some more information on JSON Forms, the JSON Forms IO webpage is a good starting point. There's a tutorial on how to get started and some more in-depth tutorials on the different features, including the ones that I have just shown today. And in case you're interested in EMF Forms, there is an EMF Forms webpage, obviously, as well, with some information on how EMF Forms works in more detail. That would be the presentation from my side. If there is any questions, I'd be happy to take any questions.
So
we have
thanks,
some
Mike.
questions.
So as of right now, we do not have any questions, but we will be monitoring our YouTube comment section, our Twitter feed, and Meetup page. So if anybody has any questions from this fantastic demo and presentation, please send them, and I will send them to Max to answer. Again, I'd like to say thank you to Maximilian for presenting and to our community for tuning in. Be sure to catch our next virtual Eclipse Community Meetup on April 11th. That will be showcasing web-based modeling tools with actually Maximilian again and Jonas.
Thank you very much for having me.
Yeah, absolutely. Thanks for coming. And thank you, community. We will see you next time.
Have a good